Alright, so in this video I'm going to tell you a little bit about quantum numbers. Quantum numbers are actually really easy, and they're going to make more sense when paired with what you already know about orbital filling notation. So, if you remember back, quantum numbers are basically the address of an electron. So it's a combination of four numbers, and that combination is specific to only one electron in an atom. No two electrons can have the same set of four quantum numbers within an atom. So I've listed over here the four different numbers. There's the principal quantum number, the angular momentum quantum number, the magnetic quantum number, and the spin quantum number. Typically, we write them like an address, and you put them with commas in between. So it will go N, then L, then M, then S. They each have a letter that represents that number. So principal is N, angular momentum is a little cursive L or a lowercase l. I use cursive because it could look like a 1 otherwise. Then the magnetic quantum number, and then the spin would be S. So you'll just write the four numbers with a comma in between. So first, the principal quantum number is nothing more than the energy level. Alright, so whatever energy level you happen to be on when looking at a specific electron, that's the quantum number. The angular momentum number tells you what shape of sublevel the electron is in. So there's actually a little key for this, and that key is this. For the angular momentum number, S is equal to 0, P is equal to 1, D is equal to 2, and F is equal to 3. So if it's in an S sublevel, you would give it the 0 designation. If it's in a D sublevel, you'd give it the 2 designation, so on and so forth. The magnetic quantum number tells you which of the orbitals the electron is placed in. Okay, so you already know the sublevel from the angular momentum number. Now you have to know what orbital within that is being used. So the magnetic quantum number, let's look at a p sublevel for a moment. Okay, any p sublevel. There are three orbitals. The magnetic quantum number can be any number that goes from negative L all the way up. Sorry, I should make this it looks like to positive L. So if we're in a p sublevel, remember S is 0, P is equal to 1, D 2, and F equals 3. So if it's P, that means we go from negative 1 to positive 1. So what this is, it's just a label to go on each orbital. We would call it the negative 1 orbital, then 0, then positive 1. See, we went from negative L all the way up to positive L. If it were an S sublevel, negative L to positive L, well, L is 0, so there's just 1, so we label that with a 0. D, I'm going to move up here to the iron designation. The D sublevel, negative L to positive L would be negative 2 to positive 2. So look, if I label each of these, negative 2, negative 1, 0, plus 1, plus 2. The 0 always goes in the middle, and then the F would go negative 3 to positive 3, giving you a total of 7. So that kind of just gives a designation for which orbital it's in. Last but not least, spin is either going to be plus 1/2 or minus 1/2. And that just is simply talking about whether the arrow is up or down. We typically put in the up arrows first and then the down arrows. So, when looking at how to use this, okay, let's just look at the carbon for a second. And let's say I want to know the four quantum numbers, or the set of quantum numbers for this electron, okay, that electron. Well, what energy level is it in? Okay, so I'm going to go ahead and actually box this electron in so I know that's what we're talking about. What energy level is it in? Well, it is in a second energy level. Okay, it's in the 2p level. So N, in this case, is equal to 2. If you look at the second one, the angular momentum number, that's the shape. Down here it says P is a 1, So the L number is equal to 1. Then for the magnetic, we go from -1 to +1, so this would be -1, 0, +1. You'll notice it is in the 0 section, so the magnetic number is 0. And then the spin is at +1/2 or -1/2. Well, it's the up arrow, so the spin is equal to +1/2. So if I were to write this as the address, you would say 2, 1, 0, +1/2. And that would be the answer. Alright, so I'm going to go ahead and erase all this now. Hopefully you have that written down. If we look at the next thing, the iron, alright, let's look at this electron right here. Well, what energy level is it on? Well, you have already gotten up to the 4th energy level, but technically this is in the 3D level. So you're going to look at the 3, and that is the current energy level that you're on. So the first quantum number is 3. That is the principal quantum number. Secondly, you have to look at the shape. Well, we know it's in a D sublevel. S is 0, P is 1, D is 2, so I'm going to put it 2. The next one tells you which orbital. I already labeled them, going from -L to +L, -2 to +2. This one is in the -2 orbital. And then last but not least, look and see whether it's positive or negative. Is it +1/2, -1/2? Well, it's the down arrow, so it is -1/2. Now, if it had asked you for the last 2 electrons that were put into iron, that's a typical question, you would say, okay, well, this arrow was the last one put in, but before I put that one in, I actually put this one in. So if you were going to do that one, you would say, okay, it's still in the 3rd energy level, it's in a D sublevel, but now it's in the +2 orbital, and it is a +1/2 electron. So you can look at any of the electrons within an element. Typically they'll just talk about like whether it's the last one or the second to last or something like that. But hopefully that will give you a good jump